Welcome to practice test 3. I have just spent the last 2.5 hours working on the recordings and then they failed. So, anywho, I'm going to go through this now a second time. If you've had a moment like that, I guess you'll have some empathy. We are going to go through this test hopefully as efficiently as possible, skip through and just work on the problems that you need. If you need help with all of them, if you need extra help, remember that there is video help for many of these questions. Okay, so here we go. Question number 1, show using the dot product to find the angle between the two vectors in degrees. So here's the formula that you're going to want to use. Go ahead and write down the formula for the test, and then also show A dot B. So in your work, do include the formula in your work, and also do include what I'm about to show, and that is the dot product. The dot product is going to be -2 times 0 plus 3 times -5, like this. And if you want a further explanation of this, see example 14 in the textbook, and in particular, example 14 is in 8.8, and that problem, that example will show you how to find the dot product in greater depth. Okay, now we want to find the magnitude of A and the magnitude of B, so we're going to show those steps as well. So you see here that I am including the work for finding the magnitudes. That's also required for you on the test. Also include your work for finding the magnitude. Make sure you use proper notation. If you can simplify anything, go ahead and do that. It's not the end of the world if you can't. Ultimately, what we want is to be able to take each of these values, -15, √13, and 5, and plug them back into this cosine theta equation. So let's do that. So now I've made those substitutions, and next I am going to figure out what theta is. Now I did write 5 √13 instead of √13 times 5, but that's completely fine. The important thing is that you have both of these numbers, √13 and 5, put here in the denominator as a product. And now we want to take the cosine inverse of this number, and then the result of that is that theta is equal to 146.31 degrees. Okay, perfect. Okay, so for this next problem, we are to construct a table for t, x, and y with at least 3 rows of values. I recommend you use some easy values like 0, 1, and 2. I changed this problem a bit because the original one was both x and y were identical. Anyway, plug in 0, 1, and 2 in for t for the x equation, and you get -3, -2, -1. And next we will do the same thing, but for the y equation, we are plugging in for this t over here. So 2 times 0 plus 1 is 1. 2 times 1 plus 1 is 3. And then 2 times 2 plus 1 is 5. So now what that means is that you have 3 points, x, y, x, y, x, y, and you want to plot those on your graph. Now the directions say that we are to use clearly defined points, so you want to make sure that these points are nice and big enough that I can see that you've plotted them, and then you're going to connect the dots with a line. And then I highly recommend also that you add directional arrows. So since 0 to 2 is moving in positive time, that means that we are moving from left to right in positive time. And so that's going to be the answer to the second part here. What is the orientation of the graph? Okay, now for question 3, you may want to make in some of your scratch work a txy table for these values, in which case you would have t values at 0 and 3, and then the x and y values are -7, 6, -5, -6. Now each one of these equations, x of t and y of t, you can see the answers here already, but you will notice that they are in the form y equals mx plus b. That is, they are going to be linear equations, so for each x and y we need to figure out what is the slope for each of these. Now this is not part of your work, this is just scratch work over here. So we want to look at the change in x over the change of t. This represents the slope of the x parameter. And so to do that, we're just going to use the same concept from Algebra 1 of finding slope. You may even want to use your table for this, but if you want to use the points directly, that is fine too. So we have -5 minus -7 divided by 3 minus 0. Now notice at time 3, x is -5, and at time 0, x is -7. So these numbers vertically here correspond. At time 3, x is -5. At time 0, x is -7. Then we're going to simplify, and we end up with 2/3. MyOpenMath has a decimal approximation over here, 0.666. Don't do that. Use this one. Okay, now at this point, it's straightforward. Once you have your slope, which is the only work you need to show for this, you use the variable t in place of x, because this is the independent variable. And then for your y-intercept, you want to see at time 0, where is x? And you can see that at time 0, x is at -7, so we complete the x of t parametric equation this way. Similarly for y, our slope will be change of y over change of t, and then that will end up being the value here, -4t, and then the value of y at t equals 0 is 6. And so there you go. Now you may not be comfortable using delta x, delta t. If instead you just want to label this m, that's okay, but you do need a subscript of x to differentiate the two. So one slope can be m sub x, the other slope is going to need to be m sub y. That's supposed to be an M and not a pitchfork. Anyway, you want to make sure that you do not use the letter M twice in the same problem to mean two different values, and that's why if you use a notation like this, it will differentiate between your two M's, and you're okay. So choose either to use the delta x, delta t, delta y, delta t, or do this, or use some sort of words. For instance, in class, I believe that in class I actually wrote out the words change in x over change in t. So something to indicate slope. Okay, next question. Okay, so for problem number 4 and the other word problems that require diagrams, take a moment to read the test directions that are posted in MyOpenMath before you get to MyOpenMath. And that way, when you get to MyOpenMath, you will not be surprised by the questions, nor will you use up valuable test time reading the directions. Okay, so let's work through the diagram first for this problem. We want to start off with a lodge. The lodge doesn't have to be labeled, but I'm going to go ahead and label it lodge so we can keep track of where it is. We do need to have at least a point, though. And then we are going to be moving 3.7 miles, 76 degrees west of south. So what you would want to do is create some sort of compass lines. Now, you are welcome to use a different color besides black or blue. Something accenting like pink, I do not mind if it's used for an accent. And if we have south and then we want to go 76 degrees west of south, that's going to put us in this direction over here. And then from the second position, we are then going to relocate. So again, I am going to be drawing some compass lines. And then next I am going to be going only 21 degrees west of south, but in a whole lot further of a direction. Okay, so the new position of Sarah is down here. This is where Sarah is now. And we have two different questions. One is, what is Sarah's distance from the lodge? So that will be expressed by this green line that I'm drawing, and which then needs some sort of variable, such as x. And then the second question is the bearing. Now in the directions it says that we need to have an equation to show how to find the bearing. But before I get to that, let's just start with fixing the diagram up a bit. I do not have any labels yet, so let me add the labels that you are going to be required to add. So first of all, I've added the distances 3.7 and 7.4. And now for the compass, 76 degrees west of south, you do notice that this green line is interrupting this angle, and so I can still represent the full angle using this arc. So this is 76 degrees, and then I have a 21 degree angle that's right in here, so let me add that. And then next we're going to add the angle that goes from this blue 3.7 line down to this south line. And this angle right here is going to be supplementary to this angle right here, because this north-south line that's going through the lodge is parallel to this other north-south line. And so that makes this angle 104 degrees. So you want to include that angle as well, which would then enable you to write what the label is, what the angle is that is this entire angle. And please draw a nice big diagram for the test so that your numbers are not squished. Mine are a little squished here. 125 degrees. Okay, now that I have these labels, I have everything that's necessary for this first question, and that is Sarah's distance from the lodge. This will be a law of cosines, so now let me write that up. Okay, so here is the law of cosines equation that you need to show on the test. Now notice here I say that give the trigonometric equations used to find the unknowns. No intermediate algebraic work between these equations and their answers is required, which means that after stating this equation, you can go straight to x. And what is x? X is going to be, x is 9.99 if you round to 2 digits right here. Now, if you ended up with 99.859, that's because that's x squared. From x squared, you then need to take the square root of both sides. This is considered scratch work, though, so I just included these lines of work for the test. So these are the ones for the test. Okay, so next we're going to figure out what bearing is, and in order to get bearing, we need to have a bearing equation. It says right here, give an equation to show how to find the bearing. So what is bearing equal to? Bearing is actually the sum of two angles, and that is these two angles here. So what we're looking for bearing, I'll show this in red, is going from the north all the way to the green line. This is what your bearing is, okay? So that is because you start at due north and then you're going towards the east. This is two distinct angles added together, and so that's what we're going to show. What two angles do we add together to get bearing? This first angle here is actually congruent to 21 degrees. These two are alternate interior angles, so they are both 21 degrees. So notice you have a parallel line here and here cut by this transversal. Alternate interior angles are congruent. And then over here you have an unknown angle, which for now I'm going to call alpha. You can call it what you want on the test. I'm going to use alpha. And then 21 goes here. So that's the equation that I'm looking for when I say give an equation to show how to find the bearing. So next I need to find alpha, and this is where the other trig equation comes into play. And so that equation is going to sine alpha divided by 3.7 is equal to sine 125 over 9.9929. So when you cross multiply, you get sine of alpha. Sine of alpha is equal to 0.3033. Now this is optional work. I set up here that you can go straight from the trig equation right to the unknowns. And so the alpha is the unknown, therefore this intermediate line is optional, but it is recommended. So I would say try to show it if you can. So alpha then is 17.6 6, 6, roughly. But we get to round to the nearest whole number here. So we're going to use alpha is equal to 18. So now we have 21 plus 18 is 39. And then once you have 39, you need to make sure that you add the directions here. So you can see here that we have N39E. And so these are the kind of directions that you would want to write on the test. And I give an example of that right up here in the directions, that your answer should look something like this, N31 degrees east. This one happens to be N39 degrees east. Okay. Okay, so next we are going to be converting equations back and forth between rectangular coordinates and polar coordinates. Here it's rectangular, down here it's polar, and then I'll do question 6 after I do questions 5 and 7. Okay, so in your notes you want to have that r squared is equal to x squared plus y squared, and that x is equal to r cosine theta, and y is equal to sine theta. Not sing, sine. Sorry about that. Autocorrect. Okay, now we're going to rewrite this equation so that x squared and y squared are on the left-hand side, and then move the negative 2y to the right-hand side. Okay, then you want to replace x squared plus y squared with r squared. Replace x with r cosine theta, and replace y with r sine theta. Alright, once we've done these substitutions, then we're going to get everything on one side and factor out r. Now, I did skip an algebra step in between here and here, which you do not have to skip, but you are welcome to skip it just as I did. This hint right here is provided for you on My Open Math, but it is not provided on the test, so keep this in mind that we do not want to keep r equals 0. So for your next line of work, you will write r equals 0, or r minus 2 cosine theta minus 2 sine theta is equal to 0. This is the result of the zero product property. But we also want to indicate quite clearly that we are rejecting r equals 0, because this r equals 0 is going to be, this is going to be just a point. So that leaves us with this equation, which when you rewrite it is this equation right here. So just move negative 2 cosine theta minus 2 sine theta over to the right hand side, and voila, you have it. Okay, so next we want to go down here and do number 7, and then I'll come back and do number 6, but because I already have these notes placed here, it will make number 7 a lot more straightforward. The first thing you're going to want to do is cross multiply, and the result of cross multiplying is 8r sine theta plus 41r cosine theta is equal to 18. Now notice I grouped the r next to the sine theta, not out in front. Same thing over here, the r is grouped with cosine theta, not out in front, and this is because I want to be able to use these substitutions up here. So now I can replace r sine theta with y, and replace r cosine theta with x. And so then I have the equation 8y plus 41x is equal to 18, and then I'm drawing this arrow over here to show you that we need to rewrite this equation in terms of y. So just use your Algebra 1 skills to rewrite this in terms of y. And so the 41x moves to the right hand side, then you divide by 8. Notice that 18 divided by 8 is 9 over 4. Okay, so then that leaves us with question number 6. So in question number 6, we are going to use cosine squared plus sine squared is equal to 1. In order to use this identity, we need to get cosine t isolated and sine t isolated, and then we'll be able to replace cosine t into this gap and sine t into this gap. So coming over to these equations, we want to rewrite each of them in terms of sine t and cosine t respectively. So sine t is equal to x over 5, cosine t is equal to y over 2, and then we come over here and we replace cosine t with y over 2 and sine t with x over 5. Then when you square each of these, you end up with y squared over 4 and x squared over 25. Notice that the answer has the x squared first. That's standard. If you have the y squared first, I'm not going to count you off for that. Also, these parentheses are not necessary. You could just write this as x squared over 25 plus y squared over 4 equals 1 with no parentheses, and you'll be fine. Okay, so in question number 8, we are dealing with vectors because we have an airplane that's heading 500 kilometers per hour. The 500 kilometers per hour at due north is a vector. It has magnitude and direction. Also, the wind blowing from the northeast at 60 kilometers an hour. Pay attention also to the fact that the wind could be blowing from the northeast, the northwest, the southeast, the southwest, and I would recommend practicing a variety of different scenarios so that you can prepare yourself for the correct diagram. Okay, so we are going to start with our due north vector. This is the airplane, and then we have another vector representing the wind. The wind is moving, this is not to scale, from the northeast at 60 kilometers per hour. And then the resultant vector, where will the airplane actually end up? It will end up over here to the left. So the wind is pushing the airplane off course. It's pushing it backwards. If you're going into a headwind, you should expect that your airplane is going to go slower than had you not had a headwind. So now we want to represent all of these things with numbers and variables. So x is going to be the speed of this vector right here. And then the green vector is going to be 60. This is the wind. And then the brown vector, which is the airplane, is going 500 kilometers per hour. Okay, now we have a 45-degree angle here, and the reason this is 45 degrees is because if this is a north, south, east, west, we are coming from the northeast. Now the northeast is exactly at a 45-45 split here. So that means that if this angle here is 45 and this angle here is 45, then these are vertical angles, and vertical angles are congruent. And then down here we have a theta, because this is unknown, and this unknown represents how far off course, how many degrees off course. So this will be theta, and then x represents the plane's speed relative to the ground. So to find x, we're going to use the law of cosines. So what we have here then is x squared is equal to 60 squared plus 500 squared minus 2 times 60 times 500 times the cosine of 45 degrees. Now then you can go straight to your answer. So you have 60 squared plus 500 squared minus 2 times 60 times 500 times the cosine of 45, and then take the square root of that number, and you should have x is equal to 459.53628. We're going to round to 2 decimal places here, so that would be 459.54 kilometers per hour. Now, once you have x, you can then use law of sines to figure out what theta is. So let me set that one up next. And so you have sine theta over 60 is equal to sine 45 over 459.53628. And then you're going to want to cross multiply. And as an optional intermediate step, now we get sine of theta is equal to 0.09. Now we use the sine inverse 0.0923. It actually goes on a little longer here. Then we end up with the correct answer of 5.30 off course. Notice you do want to round correctly to 2 decimal places. Notice also that for your diagram needs to be correct in terms of direction. So I have had students in the past get this kind of problem correct on the test in terms of the values, but they didn't get full credit because their diagram was drawn incorrectly. So just because you get the answers right does not mean your diagram is heading in the correct direction. So this is what it looks like for the wind to be coming from the northeast. All right, so I'm going to actually end the video here and actually then create a second video for you to cover the last 2 problems. I'm splitting it up because my computer is starting to get slow here. And so then hopefully the 2 videos together will give you sufficient review. See you in the next video.